Hello all, and hopefully your break was wonderful. Welcome to our first week of 2021. We're going to start with chapter 7. We're breaking up these proofs over 2 days. I'm going to give you one video with some two separate examples, and then we will, you'll have 2 days to work on these. I'll have 2 presentation problems, and then of course these ones to work through as well over the course of the next week. So this video is going to be a little bit longer, but then you'll have plenty of work time as the week continues. So get yourself ready for notes, and we're going to talk about proving biconditional statements. So the first thing I want to do a reminder of, maybe if you were here in 8th grade for logic or just from earlier in the course, is a conditional statement is if blank, then blank. We might write this out logically as saying that the x implies y. So when we do our proofs, we start with our x value, and our goal is to get to the y value, and that's how we know we're done. Now, with a biconditional statement, what this means is that we write it as blank if and only if blank. So, for example, in number 1, prove that n is odd if and only if n squared is odd. So when we see proofs like this, I will just point in sometimes, especially for me, I'll just abbreviate this as if and only if, so IFF, you'll see that sometimes. What this means is that x implies y and y implies x. So both are true, and we might write it as a single statement like this. Now, what we need to do in our proofs then is we need to prove both. So I want to prove that x implies y and that y implies x. So if I'm looking at a biconditional proof, I first recognize it, so because I see an if and only if or a similar phrasing. And then I've got my first part and my second. So we'll have two parts for the proof, and you want to keep them separate. So I'm going to start with x implies y, and so I'm going to say, so my first goal is to prove n odd implies that n squared is odd. Now, we've done this exercise several times. You absolutely can go and find those in the notes from chapter 4. But I will do a brief summary. We say that n is odd, so n is equal to 2a plus 1, where a is an integer. Then we say that n squared is equal to 2 times 2a squared plus 2a plus 1, which is again also an odd number using closure. So then we know that n squared is odd. And remember, you can always go back and look at those old proofs to help you with your new ones. Now, here's what makes a biconditional proof different is now that we've done that proof, we then need to prove the second implication, which in this case is prove n squared is odd implies that n is odd. And again, we've done this before as well. This was in the contrapositive lesson. And so I would use that and say contrapositive, which means that n is even implies n squared is even, which again, we've seen this problem before. Just as a quick review, since it has been several weeks since we've been together, we'd say n is equal to 2a, so n squared is equal to 2 times 2a squared, which is also even by closure. So now that you've proven x implies y and y implies x, so you've proven both. And again, this is not a complete proof, but I'm showing you the structure and doing a little review. Hence, n is odd if and only if, so they both imply n squared is odd. So this is basically your biconditional proofs. Now let's look at one that is significantly more complicated that we will not be glossing over as quickly. There is a small typo here that's fixed in the PDF, but I'm going to fix it here right now, is that the y is not in the exponent here. It should be x squared plus x to cubed plus x squared y is equal to x squared plus xy if and only if y is equal to x squared or y is equal to negative x. So we see our if and only if. So we have, okay, here's our first part and our second. And we are going to break it up into those two parts again, where x implies y. So in this case, I want to prove if x cubed plus x squared y is equal to y squared plus xy, then y is equal to x squared or y is equal to negative x. And this one will be mostly an algebraic proof. So I'm going to start with our algebraic statement, x cubed plus x squared y is equal to y squared plus xy. In this case, I see a lot of powers. I see a polynomial. When I solve those, I want to set them equal to 0. So I'm going to next say that 0 is equal to x cubed plus x squared y minus y squared minus xy. Then I've got a 4 terms here, so I'm going to factor using grouping. So then x squared times x plus y is equal to minus y times y plus x. So those parentheticals, while in opposite orders, are equal. So then I get a nice factored form of x squared minus y times x plus y would be the factored form, since what that means is that 0 is then equal to x squared minus y, or 0 is equal to x plus y, as we've seen in the past with polynomials. So then y is equal to x squared, or y is equal to negative x. And that's what we want to prove. So we've now done our first part. But again, that only proves x implies y. We now need to prove that y implies x. So we want to prove that if x squared is equal to y, sorry about the order change, or y is equal to negative x, then x cubed plus x squared y is equal to y squared plus xy. Now, the way that I would go about doing this is I'm going to break it into cases, since we have an or here. So I'm going to say x squared is equal to y. So our case 1, x squared is equal to y. So that means that x cubed plus x squared y is equal to, as we've seen before, x squared times x plus y. X squared is equal to y, so I can substitute that in. And then that's xy plus y squared, which is exactly what I wanted there. So case 1 works out pretty easily. Case 2 is a little bit trickier. I'll tell you this, I spent a little bit of time playing around with it. And here's where how I solved it. I'm going to give myself a little bit more room. Start out the same. And then I'm going to use my substitution first to say x cubed plus x squared times y is then times negative x instead of y. This is then x cubed minus x cubed, so that equals 0. 0 is the same as y squared minus y squared. Y squared is the same as negative y times y. And if we know that y is equal to negative x, that's the same as saying that x is equal to negative y. So then we have y squared plus x times y when we replace that negative y term there. So now we've done both of our cases. We have proven x implies y and y implies x, therefore proving the biconditional statement here. You've got a couple days to work through both these problem sets, including the presentation problems. I'm available on Zoom, email, comments, all of those. Hopefully you had a really lovely break and you're ready to get started with